In the frigid outskirts of the solar system, where sunlight is thin and the cosmos feels ancient and undisturbed, hangs a world unlike any other. Titan, Saturn's largest moon, drifts in slow, silent orbit beneath the glow of its golden parent planet. Wrapped in a thick, orange haze, Titan appears less like a moon and more like a primordial world caught between eras, a place where chemistry, atmosphere, and geology conspire to create something profoundly alien. From afar, Titan looks soft, its edges blurred by an atmosphere so dense it blankets the moon like a global shroud. But beneath that haze lies a realm of frozen landscapes, methane seas, and chemical mysteries that challenge everything we know about habitability. For decades, scientists have asked the same haunting question: is Titan's atmosphere a protective shield or an ocean of airborne chemicals so thick and strange that it blurs the line between air and liquid? The answer lies not in a single observation, but in the slow unraveling of secrets held within layers of haze that have drifted for billions of years. To understand Titan's atmosphere is to confront a world that mirrors Earth's early past, yet diverges in ways no one could have predicted. Titan's atmosphere begins where darkness meets chemistry. The moment sunlight strikes the upper layers, it triggers a cascade of reactions that produce complex organic molecules, hydrocarbons, aerosols, and chemical compounds unfamiliar to Earth except in laboratories. These particles drift downward like microscopic snow, forming a smog so thick it obscures everything beneath. To stand on Titan is to see the world through a perpetual twilight, the horizon softened by layers of drifting haze. Unlike any other moon, Titan boasts an atmosphere denser than Earth's. It hugs the surface like a blanket, shielding it from micrometeorites and cosmic rays that bombard most other icy worlds. But this protection comes at a price. The same atmosphere that guards Titan also isolates it, trapping heat so poorly that surface temperatures remain brutally cold, around -180 degrees Celsius. Within this paradox lies the duality of Titan's shroud. It shelters and suffocates, protects and imprisons. Every layer tells a story. High above, charged particles sculpt the upper haze into ghostly structures that drift like slow-moving clouds. Deeper down, the haze thickens until sunlight becomes merely a suggestion, filtered into a muted glow. And at the surface, the dense, nitrogen-rich air presses down with a weight that feels both familiar and utterly alien. To understand Titan's atmosphere is to understand that its air behaves less like the thin, invisible sky of Earth and more like a vast, suspended ocean. With almost 4 times the pressure of Earth's atmosphere and a chemical richness unmatched anywhere else in the solar system, Titan's air is not simply breathable or unbreathable, it is tangible. The boundary between Titan's sky and surface is blurred. Methane evaporates into the air like water on Earth, forming clouds that grow, gather, and eventually unleash methane rain. Storms roll across the moon with slow, deliberate force, shaping river channels and filling lakes with liquid hydrocarbons. Every cycle, evaporation, condensation, precipitation, is a mirror of Earth's water cycle, but executed with alien materials and under conditions colder than anything naturally found on our planet. To early explorers, Titan's sky might feel like drifting through a lukewarm, chemical fog, a strange ocean suspended above a frozen world. The air would seem almost touchable, dense enough to push against, thick enough to swim through if you could withstand the cold. Flying here would be effortless. Walking would feel slow, buoyant, surreal. In many ways, Titan's atmosphere is not merely above the landscape, it is part of it. But for all its strangeness, Titan's atmosphere acts as a remarkable shield. In the hostile environment of the outer solar system, where radiation is constant and icy moons lie exposed to cosmic bombardment, Titan stands alone. Its dense nitrogen envelope absorbs dangerous particles, protects organic molecules from destruction, and provides an insulating layer capable of preserving complex chemical reactions that might otherwise be impossible. This protection creates an environment where prebiotic chemistry, the kind that preceded life on early Earth, can flourish in forms that remain largely unstudied. Beneath the haze, on lockshores lined with hydrocarbon sands, simple molecules can assemble into more intricate structures. In the distant cold, chemical evolution continues at a slow, deliberate pace. Titan's shield doesn't protect life as we know it, because life as we know it may not exist here. Instead, it protects potential, possibility, the raw ingredients of future biology. Titan is a laboratory frozen in time, preserving chemistry that Earth left behind billions of years ago. There is no place in the solar system where the atmosphere feels more alive than on Titan. Methane clouds gather and dissipate like shifting continents of vapor. Ethane droplets form raindrops that fall slower than snowflakes on Earth. Winds drift with ghost-like stillness through canyons and across dunes, shaping landscapes that whisper of alien weather cycles. Standing on Titan, you might witness a methane drizzle that patters softly against your suit, or a storm system forming in the distance, towering clouds glowing faintly within the orange haze, preparing to soak the land with a rain that would instantly freeze a human hand. Rivers glisten with liquid hydrocarbons. Waves rise on methane lakes, slow and syrup-like, curling into shapes impossible in Earth's seas. In this alien dance of chemistry, Titan's atmosphere becomes more than air. It becomes a world within itself, an ocean of vapor whose tides and currents shape the moon's geography. So is Titan's atmosphere a shield or a strange ocean? In truth, it is both. It is a protective blanket that guards the moon from the harshness of space. It is a reservoir of organic chemistry that cycles through clouds, rain, lakes, and soil. It is an ocean made not of water, but of methane and nitrogen, suspended between Earth-like familiarity and otherworldly alienness. Titan's atmosphere does what few planetary atmospheres can claim. It shapes the moon from the inside out. It sculpts landscapes, fuels storms, and fosters chemical reactions that may hint at life's earliest ingredients. It carries the ancient memory of what Earth once was, and perhaps a glimpse of what other worlds might become. Within its layers lies a kind of dual nature, shelter and strangeness, potential and peril. Titan's atmosphere is not simply weather. It is a world unto itself. Even now, as spacecraft continue to study Titan from afar, its atmosphere remains one of the most enigmatic and captivating environments in the solar system. It is heavy yet delicate, protective yet volatile, stable yet dynamic. The thick haze that hides its surface is not a veil of secrecy. It is a reminder that the universe still holds mysteries waiting to be uncovered. Titan stands as a testament to the diversity of worlds that orbit our sun. Its skies, seas, and chemistry invite us to imagine forms of weather, geology, and maybe even life unlike anything we've ever known. And as we look deeper into the haze, we are reminded that Titan's atmosphere is not merely something to study. It is something to experience, to interpret, and to dream about.